Alright, you guys, this is the practice test. I hope you can hear me alright. If I'm moving too fast, just slow down your computer, but you can always rewind it and double check the work as well. Alright, so this one we're just solving these equations, and we can check our work as well because it told us to. Well, let's go and look at this equation first. Whoops. There we go. Let's make this a little bit bigger. Alright. So again, it doesn't matter which method you use. Some of you may like to draw the line through the equal sign, choose a side for x, whatever you want to do, okay? But in this case, we're just going to use properties of equality. So over here, you kind of still have to choose this side for x, and I'm going to choose the left side. So I've got my x's on the left, which means I will have the numbers on the right, like this. And what this means is the 9x is in the right place, but that plus 18 is not. So I do need to get rid of that plus 18. So I'm going to subtract 18 from both sides. Notice that I'm subtracting the 18 from that minus 18. That's because it doesn't have an x, and the 6x does. So we can't combine those terms. They're not like terms. So this 18 minus 18, pretty much this just goes away. So let's go ahead and take that away. So you'll see that disappear like this. And what we're left with is we've got this 9x equals 6x minus 36. Now the 6x is on the right side of the equal sign, but we see that we wanted the x's on the left. So we're going to have to move that as well by subtracting 6x from both sides, like this. And in return, that 6x is going to go away. So this just disappears. And what we're left with is 9x minus 6x gives us 3x's. This is equal to that negative 36. From here, we just need to divide by the coefficient of x, which is 3. And we'll find that x is negative 12. Alright? Now that's not necessarily all we need to do. That's 12. It did tell us to check. I am not going to grade you on whether you check or not. If you don't check, though, just understand that you are taking a chance. Alright? So go ahead and check. You can use a calculator to check. All we're going to do is replace the x values with the x value that we found. X is negative 12. And what we should get is the same number on the left side as on the right. Alright, so let's go ahead and put negative 12 in for x. We've got the 9 times x, which is negative 12. I'm going to add 18, well, not to both sides, I apologize. And we've got this 6 times the same x, negative 12. And that's minus 18. So we're just going to solve both sides. Let's look at the left side first. We've got to do the order of operations here. So we've got to do 9 times negative 12. That's going to give me a negative 108. And then I'll add that 18. Okay, so if I stay focused on the left side here, we can see that this is going to give me a negative 90. Now, if we've done this correctly, we should find that it is negative 90 on the right side as well. So let's go ahead and find out. We'll take this 6 times negative 12, which is a negative 72 minus 18. Negative 72 minus 18 is negative 90 as well. We can see that negative 90 is negative 90, and so we've checked this. And we know now, we have no doubt that x is negative 12. Alright, number 2, this one's, I wouldn't say it's tricky, but there's several different ways we can look at this. Some of you may just choose to distribute or find the common denominators. I'm going to kind of take that route to find common denominators. I'm going to rewrite the left side as a negative 2, x minus 12. And this is all over 3. This is going to equal 1 over 6x minus 4. So if we want a common denominator, our lowest common denominator is 6. So if I multiply the left side by 2 over 2, essentially I've just multiplied the left side by 1, which doesn't change anything. Alright? But I will have to take that's a 4 over 1, and I'm going to have to multiply both of those by 6. That's going to give me a brand new equation. I have a negative 4 x minus 12 all over 6 equals, I'm going to make that a x over 6 minus 24 over 6. Well, now that we have common denominators, and I saw this on the homework, once we have common denominators, we can just wipe that out, okay? So in other words, I can just erase all of this stuff, all the denominators, getting rid of the fractions, which can be helpful, alright? I don't know if it's helpful for you, but that's kind of what I'm looking at. Now this looks like it's going to be much easier to solve than with those fractions. From here, now I can distribute that negative 4. That's going to give me a negative 4x. That's plus 48 there, alright? This will equal x minus 24. Now don't forget that this is a plus, okay, because you have a minus 12. And that negative 4 times 12 would be a negative 48. Minus a negative 48 would make that a plus 48, alright? Here we just need to choose a side for x's, and I'm going to choose the right side. It doesn't matter which side you choose. I'm just going to choose the right, and I'm going to put the numbers on the left. So the negative 4x is on the wrong side. I will need to add 4x to both sides. Okay, now that's a 1x there. So what I'm left with is this 48 equals 5x minus 24. Now at this point we can see that the 5x is on the right side, 48 is on the left side of the equal sign, but that minus 24, it's on the incorrect side. We'll need to get rid of it by adding 24. Okay, that's going to cancel itself out. But if I do it to one side, I must do it to the other side as well. So from here, we have this 5x, this minus 24 plus 24, that make a 0, so we can cancel that out. 48 plus 24, that will give me 72. Now dividing by 5. So here's another thing with this. We can see those 5's cancel out. This gives us x equals 72 fifths. You can keep it as a fraction like that, improper especially. Mixed numbers aren't going to necessarily do us a lot of good, especially if you're going into math 1050. I'm okay with the mixed numbers, but an improper fraction usually works much better. If you're going to turn this into a decimal, you should get 14.4. So any of these will work there for x. Now that we've solved for it though, again you can use a calculator for this, but I can replace the values of x with the value that we found, and we can see that x here is 72 fifths. I'm going to keep that as a fraction actually, and let me rewrite this equation, alright? So I've got negative 2/3. This is 72 fifths now, minus 12 equals 1/6 times x, which is 72 fifths, minus 4. And again, hopefully we'll find that both sides are equal to each other. Alright, now continuing with the order of operations, again I'm just focusing on the left side. I'd have this 72 fifths minus, with a common denominator, would have 60 fifths in parentheses there. This will eventually all be multiplied by negative 2/3. But I get a negative 2/3 times, this is going to be 12/5. Multiplication of fractions, I'm just going to multiply the two numerators. 2 times 12 is 24. And 3 times 5 is 15. And if I wanted to, I could simplify this, would get a negative 8/5. Alright. Now on the other hand, we've got this right side, so this is split. And again, on the right side, we should get that negative 8/5. So if we take 1/6 times 72/5, what we'll get is a 72 over 30. And yeah, some of you may want to cross-simplify, cross-cancel, whatever you want to call it. And it looks like that is going to simplify to a 12/5. Now, we still need to subtract that 4, so don't forget about that. But we need common denominators. So we have 12/5. 4 would be 20/5. And what we'd end up with is a negative 8 over 5. So we can see that the left side is equal to the right side. And we've just checked our work. And that's a good way, again, on a test to know that you've got the answer right. That is, again, assuming that you have checked it correctly. So use calculators, show your work, and be careful out there. All right, number 3 is kind of the same thing. Some of you may choose to distribute first. Some of you may want to divide. I don't know. I'm going to distribute first here. Then I'll distribute that 4 there, okay? I'm going to go ahead and use that switch and stay game method, so it won't matter anyways. You've got to distribute. This would give us 36x minus 48 plus 10 equals 4x minus 56. So I don't know if you guys remember this method. We're going to draw a line through the equal sign. That's going to bring it down right here. I'm going to choose the x's to be on the left and the numbers to be on the right. So the 36x is going to stay positive 36x. Negative 48 will switch to a positive 48. Positive 10 will switch to a negative 10. 4x will switch to a negative 4x. And negative 56 will stay as negative 56, all right? So we've got the x's on the left. 36 minus 4 will give us 32. 48 minus 10 minus 56. And looks like that's going to be a negative 18. So from here, we just need to divide by the coefficient of x, which is 32. And we can simplify that x. It's going to be a negative. Looks like we can divide by 2. Yeah, not 3. Alright, so let's try 2. That would give us a negative 9 and 16ths. I can finish that there. Some of you may want to write the decimal. I don't know. Again, that's up to you. And I don't care which one you do. The decimal looks like 0.5625. But again, you get to decide. Okay? Final thing we would want to do on this is check. So if x is negative 9/16. Alright, so again, notice all I've done is I've rewritten the equation, but I've replaced the x's. Okay, and again, we're saying that x is a negative 9/16. So it looks like everything else is going to stay the same, but we've got to multiply inside those parentheses. So 3 times negative 9/16 would give us a negative 27/16. Plus the 10 equals 4. And in this parentheses, we just need common denominators. And that would all come out to negative 233 over 16. Yeah, that's negative. All right. Well, go ahead and keep working that left side. This 4 here, this would actually end up turning into a, get it erased first, that was a 4. But that would be a 64 over 16 right there. Because we need common denominators to subtract. Again, you can use a calculator, it doesn't matter. So that's going to reduce this down to 12. It's going to be a negative, instead of 16, negative 27 minus 64, negative 80, 91 is what it looks like, plus 10, equals, and we can simplify this side, the 4 will cancel out there, it'd be a negative 233 over 4. All right, that means we just got to work with the left side, and that's great. So that's a 12 times a negative 91. Looks like that's going to give us a negative 1092. So here we've got a negative 1092 over 16. Plus, and I'll go ahead and work with that 10 right now. I know I can simplify that, but I'm going to give these common denominators, then we'll reduce later. It won't matter whichever you do. But if I multiply that by 16, I'll have 160. So negative 1092 plus that 160, looks like that's going to give us a negative 932. And don't forget your denominator here is 16. Now this needs to equal this negative 233 over 4. So we should be able to simplify this by 4, is what it looks like. Again, you can use your calculator to do this. You have a denominator 4. And the numerator of negative 233. So these are the same, which means that we did our work correct, and we could justifiably write that x equals negative 9/16. Now make sure to take your time on these on the test, all right? Want to make sure you get a good score on it. You can watch this video as many times as you need as well. All right, number 4. So let's go and distribute this 6 here. So 6 times x plus 6 times 4, that's going to give me 24. That's minus 20 equals 4x plus 16. And don't forget, that's minus a negative. That's going to give us a plus at 3x. All right? Now from here you can combine like terms on both sides. That would give us this 6x. 24 minus 20 is going to give us a positive 4 equals, we'll combine the 4x and the 3x to get 7x plus 16. Right? From here we got to choose a side for the x's. Let's go ahead and choose the left side and the right side for numbers. I know some of you intuitively would look at this and subtract 6x from both sides, but it's not going to matter in the end. So let's go ahead and look. This plus 4 is on the wrong side. We're going to subtract 4 from both sides. It's going to give us a 6x equals 7x plus 12. From here, we'll subtract the 7x from both sides. Okay, so this one goes away. That's a 0 now, leaving us with the 12. This should equal a negative 1x. Well, the x can be negative. We need it to be positive, so we'll divide by negative 1 on both sides. And that tells us that x equals negative 12 there, all right? So now that we know x is negative 12, let's go ahead and replace the x's with that negative 12. So we'll go ahead and get rid of everything. Alright, so you can see I've replaced all the x's with those red negative 12s. And let's go ahead and just use the order of operations to solve this. On the left side of the equal sign should be equal to the right side of the equal sign. So let's go ahead and check. The first thing we've got in the parentheses on the left here is this negative 12 plus 4. It's going to give me a negative 8. And we've got 6 times that minus 20. 6 times negative 8 is going to give me a negative 48. Minus that 20. And finally we end up with a negative 68. So on the right side we should get a negative 68 as well, as long as we've done this correctly. So 4 times negative 12 is negative 48, plus the 16, minus negative 3 times negative 12 is a positive 36. Now it's important for you not to get all of these signs mixed up. Keep track of those and take your time with them, alright, so that you don't make any mistakes there. So what we have is a negative 48 plus 16. That's going to give me a negative 32 minus this 36. Finally, we can see that this is a negative 68. And we did our work right before. X is negative 12. Alright, now we have number 5. Let's go ahead and figure this one out. Now one of the big problems I've seen on the homework is where if this plus was a minus, that we're not distributing that correctly. So make sure if that is a minus, that you would distribute that. It would change that minus 1 to a plus 1, if that were a minus, okay? So keep track of that, and I try to remember that on the test, all right? Because, again, a lot of the mistakes I see on the homework are related to that. So we can see if we just want to find a common denominator on this, which would be quite nice. Our lowest common denominator is 12, so if I multiply this expression by 3 again, that 3 is going to apply to both the h and the minus 1. And I'll multiply the 4 by 3 as well. And I'll do the same thing on this fraction as well. So this should give me a common denominator of 12. I've got 2 plus h over 12 plus 3 times quantity h minus 1 over 12 equals 3 over 12. Well, that's very nice, because from here I can just rewrite the expression without any denominators. 2 plus h plus 3 times h minus 1 equals 3. So distributing the 3 would have 2 plus h plus 3h minus 3 equals 3. Combining like terms on the left side, this would give us a 4h minus 1 equals 3. From here we'll just add 1 to both sides. Sorry, that's a plus 1. I had a space there. So this becomes a 0. And 3 plus 1 is 4. And the 4h remains. Finally, we'll just divide by 4 on both sides. That will tell us that h equals 1. Now that we know that h equals 1, let's go ahead and go back and we'll check our answer on this, okay? Alright, so we're saying h is 1. Let's go and replace those h's. Alright, finally we can check this. So I replace those h's with those red ones. I've got 2 plus 1, which is going to give me 3/12. Plus 1 minus 1 is 0/4. This should equal 1/4. And yes, since that's a 0/4, it's going to be a 0. We can just get rid of that there. So does 3/12 equal 1/4? Well, let's divide 3 by 3 and 12 by 3 and find out. 3 divided by 3 is 1. 12 divided by 3 is 4. And looks like we've done that correctly. So h actually is 1. Alright, now that we've got that, let's go ahead and get started on 6. We'll just use combining like terms, but we will have to distribute the 6 and the 3 first. 6 times the 9 is going to give me 54 minus 36x. equals 30 minus 45x plus 4x. On the left side, we don't need to combine like terms, but we can see that negative 45x plus 4, that'd give me negative 41x. And everything else just remained the same. So writing it out, we've got this. Okay? So there's nothing else to combine here, but what we can do is choose a side for x, and I'm going to go ahead and choose the left side for the x's and the right side for the numbers. So 54 is a number, but it's on the left side with the equal sign. We've got to move it. Let's subtract 54 from both sides. And I've got the negative 36x. That's a 0 now. And this is equal to 30 minus 54 is a negative 24. And that's minus 41x. Next thing we can see that minus 41x is on the wrong side, so I'll add 41x to both sides. Alright, so that gives me a 0 right there. And what I have left is a negative 24 and negative 36x plus 41x. That's going to give me a 5x. So continuing this process, we're going to divide by 5 on both sides so that the x is by itself. And we'll find that x is a negative 24/5. I believe if you want to use the decimal on this, looks like it's going to be a negative 4.8. We can use any of these values. It's up to you. You can use a calculator. It won't matter. Okay, but I like the fraction, so I'm going to stick with it. And we'll solve this. We'll check our answer using the fraction. So I've got my x as negative 24/5. Let's go ahead and replace all the x's with negative 24/5. Alright, so I've rewritten this. And actually it looks like I forgot a parentheses there. That's okay. We got it in time. So, looking at the left side, let's work with those parentheses. It looks like we're going to have that 6, 9. That's going to end up being a plus because of that negative. So that's 120, 144 fifths. 6 times 24 fifths there, okay? And this is going to equal 3 times 10 minus... I'm going to go ahead and simplify this. I've got a 15 and a 5 there that can simplify. That plus, that's a negative, so that's going to end up being a plus. 3 times 24... 60, 72. And we're going to add that to 4 times negative 24/5. So it looks like that will end up being a minus. So we got 80, 96 fifths. Okay. I know there's some big fractions in here. Don't be intimidated. You can use a decimal if you choose. But just make sure that you use the correct decimal if you're going to do this. If it's repeating, you may want to use the fraction instead. So I'm going to rewrite this using the left side, rather, using inside the parentheses, using common denominator. So I have 45 fifths plus 144 fifths. That's going to give me 6 times 45 plus 144. Looks like it's a 189 fifths. And if I multiply 6 times 189 fifths, let's go and see what we get. I'm going to use a calculator for this. 1134 fifths. So on the left side, I get 1134 fifths. On the right side, I should get the same thing. Let's go and work inside these parentheses right here. 10 plus 72 is going to give me 82. And this is 3 times that quantity minus 96 fifths. 3 times 82, so that's 246 minus 96 fifths. We do need common denominators. And right now that 246 has a denominator of 1. So I'm going to take 246 and multiply that by 5 to get common denominators. It's going to give me 1230. So So now I have a 1230 over 5 minus 96 over 5. And I should get the same thing as I did over here, okay? 1230 minus 96 is 1134 with the denominator of 5. Just as we expected, our answer was correct. And we've checked this thing off, okay? So our final answer here is this x equals negative 24/5. I know that's a lot of work, but it's worth it, all right? It's worth it to make sure that the answer is correct. You guys are going to be putting a lot of work into this class. This is a good test to start with a high score with, okay? All right, for number 7, I'm going to put this at the bottom. I hope you guys are okay with that. But I know I have 4 consecutive integers whose sum is 90. So if I take x, consecutive integers means they're all, well, they're consecutive. They're right after each other. So I have x. The next term would be x plus 1. The next term would be x plus 2. And our final term would be an x plus 3. Now, if it helps, I can put parentheses around there to show that this is going to be my 4 terms right here, okay? And they're consecutive. They're one after the other. I don't know if you want those there. In any case, without them, you may be able to see that better. So we're going to do it like this, okay? So this should equal 90, okay? Because it told us the sum of these is 90. So let's combine like terms. We have 1, 2, 3, 4 x's. And we have the 1 plus 2 plus 3. That's going to be plus 6. Will equal the 90. Well, we'll isolate those x's by subtracting 6 from both sides. This is going to give me a 4x equals 84. Finally, to solve for x, which is my first term, I'll divide by 4 on both sides, and we see that x equals 21. So the next consecutive integer would be 22, the next one's 23, and the fourth one is 24. So the way that we check this is a little bit different than what we did in those previous 6 problems. I'm just going to add all these together and see what I get. And again, this should equal 90. 21 plus 22 plus 23 plus 24. As it turns out, this does equal 90, so we know that we must have done that correctly. I'm going to show you guys the other way to look at this. I know we kind of discussed it a little bit in class, but if you take 90 and divide it by 4, that would be the average of the numbers. That's 22.5, okay? So if 22.5 is right in the middle of all the numbers, then you'd have 22 and 23 would be the 2 center numbers. If we go one out in both directions, we would have all 4 numbers. And you can add those together, just like we just barely did, and find that the sum of them is 90. Let's go ahead and do number 8. I hope that's big enough for you guys to see. In any case, if you can't, just open up a new window with the actual practice test that you can download from Canvas. All right, the parameter is the sum of all 3 sides. So I'm going to add all these together. 2.5 plus 5.5 plus the 3x plus 16. And it tells us that the parameter is 137. So if we combine like terms, that's a 5.5x and a 2.5x. If we combine all the x's, looks like we'd get 8, 9, 10, 11 x's. Plus that 16 equals 137. Subtracting 16 from both sides, looks like we get 11x equals 121. Well, that's convenient, because 11x, so if we take 11x equals 121, I'm sorry I ran out of space. Let's divide by 11 on both sides. X is 11. But that doesn't mean x is 11 inches. In order to solve these, we still have to replace those values with 11. Let's go ahead and do that. We need to find this side. So we have 2.5 times 11. And it looks like this is going to be 27.5, I think. Let me double check that. Yeah, 27.5 inches. So this is one side. The next side was 5.5 times the x, which we're saying is 11. So 5.5 times 11, that gives us a 60.5 inches. Don't forget to label these. And the final one is 3 times 11 plus 16. So we got 33 plus 16. And our final side looks like it's going to be 49 inches. Well, there's a way we can check these. Let's say that these are our answers. Let's go ahead and look at a way that we can check this, okay? So we got 27.5, 60.5, and 49. We can put 0.0 if you choose. We're just going to add all these together and see what we get. Alright, so we need to get 137 inches as perimeter, which is what it was to start out with. So we went ahead and checked that answer, and it looks like 27.5 inches, 60.5 inches, and 49 inches will do. Alright, looking at 9, looks like we want to solve for C. So let's move all the terms that don't have a C to the left side. Because right now all the terms with C's, these two, are on the right side. See, there's no C's on the left side, so let's go ahead and move those. I'll move those terms. So let's give ourselves some space. I'm going to subtract 4WH from both sides. Well, S cannot subtract 4WH. So this turns into a 0, so that goes away. But on the left side, we've got S minus 4WH. Equals the rest of that stuff. We got 4CW plus 4CH. Right? So all the C's are on the right side rather. All right. From here we've got to factor out the 4, and we can factor out just the C if you want. I suppose it doesn't matter. Let's go ahead and factor out the C and see what we get, because then we can just divide. So let's go ahead and factor out the C from the left side, and inside the parentheses, the left term here has a 4W remaining, and the right term has a 4 and an H remaining, and the left side remains the same. From here, all I need to do is divide both sides by 4W plus 4H. What this will do is cancel out all of this stuff right here, okay? It essentially becomes 1. Anything divided by itself is 1. And we can see then that our answer is actually written for us right here. Now you could simplify that, I suppose. You could factor out a 4 and then cancel out the 4, but it wouldn't do anything to the S. So you can keep it like this. You may simplify it in other ways, but that's up to you, okay? I would stop right here. This isn't too bad. We found out what C is. Right, on this one we got to solve for F. So let's go ahead and move the CA right here to the other side. We'll subtract CA from both sides. They're going to give us L minus CA equals, so this goes away, and we're left with 3N minus 4 times F. From here we should divide both sides by 3N minus 4 for the same reason we did divide by that whole quantity on that last problem. This leaves us with an F on this side, and we have L minus CA all over 3N minus 4. And we're done. Now we're going to start moving a little bit quicker on these. I know it's taking a lot of time, so if you have more questions, just feel free to come and ask. Or email me, rather. Alright, so on this one, first thing I need to do is distribute that 3. So I've got a 6x minus 12 and the parentheses, and I'll distribute that -7. Okay, so this is where I'm at. Inside that right parentheses, I can combine like terms, and that would give me, alright, from here I will need to distribute that -6. So I have this. Okay, and I'm going to keep the x's on the left side. So I'm going to double up on the work here. I'm going to add 63 to both sides. But I'm also going to add this 36x to both sides. So what I end up with here is a 15x is greater than, so that gets to 123. So I'll take x and divide it by 15, both sides by 15. This gives me x is greater than 123 over 15. Now this is not finished because that's just the inequality. It wanted us to write this in interval notation, and while correcting the homework, it seems like some of you guys forgot to do that. So since x is greater than 123 over 15, so if I give myself a number line right here, and I make this positive, it's 123 over 15. Okay, so it's not equal to, so we have to indicate that it's not included. But all the values to the right are going to be greater than x, okay? And you could check that. Try something like 100. Would 100 work? Of course, you'd want to try it in this original equation, inequality rather. Well, we can see in the graph that that's going to work. Interval notation for this is just 123 over 15, and it's going to go to infinity. Let's go ahead and do this one. We've got 23y minus 8y minus 6. Okay, now don't forget that since we're subtracting this, we're going to take the opposite values of each of these, and then you can change that to plus if you want. This is less than or equal to 16y minus 20 plus 18. Combining like terms on both sides, we got this 23 minus 18. That's going to give me a 15y minus 6. It's less than or equal to 16y negative 20 plus 18 will give me a negative 2. And from here, I'm going to put the y's on the right side and numbers on the left. So I'll subtract 15y. The reason I'm doing that is because that'll give me a positive y on the right, okay? So let's go ahead and add 2 to both sides as well. So this tells us this goes away, this goes away. But not, since the coefficient of y is going to be positive, and it's going to be positive 1y, we won't have to flip the sign for anything. So negative 6 plus 2 is a negative 4. So negative 4 is less than or equal to y. Let's go ahead and graph this. So if we take a line, which we'll do, got a line, and we've got a negative 4, negative 5, negative 3. Don't forget that as the number line goes to the left, that the negatives are going to get bigger, okay? So this is included, but y is it's bigger than negative 4, so to find those values, it's going to have to open up to the right, and we can see that all of these values here to the right are going to be bigger than negative 4, and it's included negative 4 because we have a square bracket. Last thing we would need to do is write this in actual interval notation, so we can see at negative 4 it's going to go all the way to the right until you get to infinity. And we can box this in as well as the graph if we choose. Definitely box those in so I can find your answers on the test. Some of you put 2 answers for one problem on the homework, but that's not going to work very well on the test, okay? Alright, so this is a compact compound inequality, and we can go ahead and solve this. Again, if you want to write this as 2 separate inequalities, that's fine. It's really not going to make a difference here, okay? But on the other hand, just because I know this is kind of dragged out a little bit, let's go and subtract 3 from both sides. That's going to turn that into a 0. We've got a 3x less than or equal to negative 3, but greater than or equal to negative 12. From here, we'll divide all of these terms by 3. So that goes away. We have x is less than or equal to negative 1, but greater than or equal to negative 4. So what does this look like? Let's go and look on a number line. We have negative 1, negative 2, negative 3, and negative 4. Well, x is greater than or equal to negative 4, so we do need our square bracket, but it's less than or equal to negative 1, so also a square bracket right here. So it looks like it's going to be everything in between, because if we go farther to the left or the right, this original inequality will not work. You could use 0 for x. It would work for one of these, but not for the other. And it has to work for both on this. Number 15 is a little tricky here because it's asking what absolute value will ever be less than a negative. Well, any absolute value will always give you a positive number. So even if we found out, if we used, for example, 3/18 would have a 0, absolute value of 0 is less than a negative 2 here. Well, 0 is not less than negative 2, okay? And that's about as low as we can take in absolute value. So in this case, we can see that there's no solution to this. But let me go ahead and turn the tables here, okay? If we said that we had an absolute value of 18x minus 3 is greater than negative 2. Okay, well now we can see that this absolute value is actually always going to be greater than negative 2. No matter what. Again, the smallest value we can get out of it is 0. And 0 is greater than negative 2. Again, this is just a separate example. Okay. So this is separate. And this is always going to be true. So in actuality, the interval for this one is negative infinity to to infinity. So keep that in mind. I don't remember if the test switched that around or not, but just be aware that sometimes it's all the real numbers, which as an integral shows like this. Sometimes it's no solution, okay, because we have to know that the absolute value could never be less than a negative. Alright, so this one's a little bit different. Okay, so some of you remember, since it's less than or equal to 18, we'll need to take 3x plus 72 and we'll sandwich this between 18 and negative 18. And if you want to remember, if you want to look up the rule for this formula, whatever you want to call it, it's on page 105 in the book. And from here we would subtract 72 from every term, which would then leave us with this 3x is less than or equal to, looks like this is going to be 54, and this one will be a negative 90. And we'll divide by 3 everywhere. So this goes away. We have x is less than or equal to 54 divided by 3. Looks like that's an 18. And negative 90 divided by 3 is negative 30. So if we were to require to graph this, we have a line over here. And way over here it'd be 18. And over here it'd be a negative 30. Well, x is less than or equal to 18, so we have a square bracket here going to the left. Negative 30 is less than or equal to x, so we have a square bracket here, but going to the right. And we can see that both of these colors exist in between negative 30 and 18 there. So our integral notation would be negative 30 to 18. Alright, 17 through 20, I believe we just need to solve for x on these. Now remember, we've got to write this twice though. So we've got 6 plus 12x equals a negative 54. But 6 plus 12x is also going to equal positive 54. We'll subtract 6 from both sides on both equations, giving us 12x equals negative 60 on this one is a negative 12x. Sorry, that was plus, I'm sorry. So that's a positive 12x equals a 48. Well, that's nice. That seemed to work out pretty well. We'll divide by 12 here and here. So we got x equals negative 5. And it looks like x over here dividing by 12. X is 4 right here. And we can write this as x equals 4 and negative 5 like this if you choose. It's up to you. Now you can check this by replacing x with either 4 or negative 5. You want to check both. 6 plus 48 would give us 54, the absolute value of which is 54. That's great. Then you can use the negative 5 as well. Alright, in order to solve this one, we've got to move all the absolute values to their own sides. We're going to add 9 to both sides. So this gives us the absolute value of 6x. See, this goes away, and we've got this equal to 36. So we'll need to write this twice again. 6x equals 36. And also 6x equals negative 36. Okay, because it can equal both. Alright, whatever value of x is going to give us whatever's inside the absolute value, if it's negative, it's going to spit out that positive 36. So from here, we'll divide by 6 on both sides and find that x is 6. And on the other side, we'll divide by 6 on both sides and find that x is negative 6. So we have two answers here, and you can write this, once again, just as x equals 6 and negative 6. All right, this last one, if you have the absolute value on both of these, it's not going to matter which one you choose. But if we rewrite this, let's say that we want to keep 9y plus 3 the same. Okay, so we're going to say this equals 7y plus 11. But we're also going to rewrite this 9y plus 3 equals a negative 7y plus 11. Alright? So let's solve the equation on the left. We'll subtract 7y from both sides. And we'll subtract 3 from both sides as well, giving us a 2y equals 8. So it looks like y is 4 right here. So that's one of our answers. Y is 4. On this other side, we've got this 9y plus 3. That's great. 9y plus 3 equals, but we've got to change the signs on the inside of the parentheses, so we got a negative 7y minus 11. Now when we solve this, we'll add 7y to both sides. And we'll subtract 3 from both sides, giving us a 16y equals a negative 14. And we'll divide both sides by 16 and find that y is a negative 7/8. And you can go back in and check that in the absolute values to make sure that they work. Okay, I'm going to actually go ahead and show you that. So let's give ourselves some space here. All right, let's go ahead and try that out. Let's start with 4, all right? So the absolute value of 9 times 4 plus 3, it should equal the absolute value of 7 times 4 plus 11. Well, the absolute value, 9 times 4 is 36 plus 3. And 7 times 4 is 28 plus 11. That's going to be the absolute value of 39 equals the absolute value of 39. That's going to be true. So we still have to check that other one. So we have absolute value of 9 times negative 7/8 plus 3. Sorry, I guess I need some more space. This will equal the absolute value of 7 times negative 7/8 plus 11. Absolute value. All right, well, looks like this is going to give us negative 63/8 plus 3, common denominators. And we end up with a negative 39/8, which as an absolute value is going to give us a positive 39/8. So the other one should give us the same thing. Let's go ahead and check that. Absolute value of negative 49/8 plus 11. So we need common denominators again. And this is going to equal 88 minus 49. Yep, that's going to be an absolute value of 39/8, which would just be the same thing as 39/8. So it looks like we've checked our work, And our two answers were correct indeed. All right, number 20 is our final one. Let's go ahead and take a look. So the absolute value of 1 plus 4n, sorry, I guess I'm just rewriting this. 1 plus 4n over 24 can equal positive 10, and 1 plus 4n over 24 will equal a negative 10. All right, so multiplying both sides by 24 on this one. I'm going to solve this one first all by itself. These cancel out, and we have 1 plus 4n equals 240. Subtracting 1 gives us a 4n equals 239. That's not going to go into 4 anyways. But if I divide by 4 on both sides, I get my answer, 239 fourths. There's my first answer. Let's go and look at that second one. So once again, I'm going to multiply both sides by 24. Let's get that out of the way so it's not confusing this problem. So I'll multiply by 24. Both sides, these cancel out. I have 1 plus 4n equals negative 240. Subtracting 1 from both sides, I get a 4n equals a negative 241. And finally, we'll divide by 4. This can't be simplified, so our final answer on this part as well, n equals negative 241 fourths. You can turn that into a mixed number, that's alright. Okay. And you can check your work if you choose. I'm going to go ahead and keep those the same. I'll let you check them. Get some good practice checking. If you make it a practice, you'll just do it naturally when the test comes. So it's not a big deal for you. I hope you do that. I hope this has been helpful. And good luck on the test on Wednesday, you guys.